Voyager 1's silent journey. Ambient narration beyond the Heliopause. Segment 1. The beginning of a journey. Imagine, if you will, a moment in time, September 5th, 1977. The world was different then. Humanity stood at a threshold, about to reach beyond itself in ways that would echo through the decades to come. On this date, NASA launched a spacecraft that would become one of the greatest achievements in the history of space exploration. We call it Voyager 1. This wasn't just any spacecraft. It was born from ambition and dreams, designed to explore what no human-made object had ever explored before. The engineers and scientists who created Voyager, one imagined it would travel to the outer planets, studying their mysteries and the very boundaries where our solar system fades into the cosmos beyond. The Voyager 1 spacecraft carries within it the power of 3 radioisotope thermoelectric generators. These remarkable devices convert the natural heat from decaying plutonium into electrical energy, a silent transformation that has kept this distant explorer alive for decades, far from the warmth of the sun. This engineering feat would prove crucial to everything Voyager 1 would accomplish. When scientists designed Voyager 1, they equipped it with instruments of extraordinary precision. Cameras to see what human eyes could never witness, spectrometers to analyze the composition of distant worlds, and plasma detectors to sense the invisible forces that fill space. Each instrument was carefully chosen, carefully calibrated, designed to function in the harsh environment of deep space, where temperatures drop far below zero and radiation fills the void. The path that Voyager 1 would follow was calculated with meticulous precision. Its trajectory was optimized specifically for a flyby of Saturn's moon, Titan, a world shrouded in mystery. This single decision, the choice to aim for Titan, would ultimately determine the entire future of the spacecraft's journey. After this encounter, Voyager 1 would be flung out of the orbital plane of our solar system, headed toward a destination that would take it beyond anything previously imagined. Communication with such a distant spacecraft presented unprecedented challenges. To maintain contact across these vast distances, Voyager 1 was equipped with a high-gain antenna measuring 3.7 meters in diameter. This metallic dish would remain the only thread connecting this explorer to home, the only way to receive the commands and wisdom of those who built it, and the only way to send back the knowledge it gathered about worlds previously unknown to humanity. But Voyager 1 carried something more than scientific instruments and communication equipment. It carried a message, a time capsule, a golden record holding the sounds and images of Earth. Greetings in 55 languages, music from different cultures across our world, images of the Earth and its life, all preserved on this disc of gold-plated copper, created with the hope that someday, somewhere, someone or something might find it and know that we were here, that we existed, that we had looked outward and wondered. This record represents more than metal and electromagnetic signals. It is an artifact of hope, a message in a bottle cast from our tiny planet into an ocean that has no shores. It is intended to communicate the story of humanity to any extraterrestrial intelligence that might encounter this silent explorer in the vast darkness of space. It is a representation of the diversity of life on Earth, a statement about who we are and what we value. The spacecraft that carried this record is the most distant human-made object from Earth. Even now, after all these decades, no human creation has traveled farther from its home. Voyager 1 represents the furthest reach of human endeavor, the farthest extension of our curiosity, our desire to know what lies beyond our world. And yet, this journey was only beginning. The story of Voyager 1 is not just a story of technology and engineering, though those are remarkable. It is a story of human ambition, of our desire to understand our place in the cosmos, and of the incredible discoveries that await when we dare to look beyond our own horizon. The spacecraft moves through space at approximately 17 kilometers per second, about 3.5 astronomical units per year, carrying with it the hopes and dreams of an entire species reaching out into the unknown. Segment 2: Mission and Extended Purpose. As Voyager 1 began its voyage, the original mission seemed clear and definable. Study the outer planets. Reach beyond them to understand the boundaries of our heliosphere, that great sphere of influence created by the sun's radiation and magnetic field. But missions, like lives, often take turns that their planners never anticipated. What began as a planetary survey would evolve into something far more profound and far-reaching. The mission to study the outer planets was only the beginning. Scientists realized, as they gathered data from the Jupiter and Saturn flybys, that there was so much more to discover. The boundaries of the heliosphere, that invisible envelope of solar influence, extended far beyond what they had originally theorized. More science awaited, more knowledge could be gathered. The mission would be extended, expanded, transformed. The decision to extend Voyager 1's mission meant sending the spacecraft to study the outer heliosphere and interstellar space, regions never before explored by humanity. This required careful management of the spacecraft's limited power supply, rationing electricity to essential systems, dimming lights, reducing heating. Every watt mattered when power came from the gentle decay of radioactive material, and the spacecraft was farther away than any human creation had ever ventured. In 2017, over 36 years after its last thruster firing, mission controllers decided to fire Voyager 1's thrusters again. This action, successful in its execution, extended the spacecraft's mission further still. After so many decades of silence from those systems, they responded. The spacecraft's trajectory adjusted slightly, corrected minutely, and Voyager 1 continued on its path, renewed in its purpose. The expectations for how long Voyager 1 could continue sending scientific data back to Earth were established with careful analysis. Scientists predicted that Voyager 1 is expected to continue sending scientific data until at least 2025. Beyond that date, as power reserves dwindle further and the radioisotope generators continue their slow decay, the spacecraft might send only engineering data, operational information about its status and condition, until around 2036. This timeline, stretching across nearly 6 decades of continuous operation, represents one of humanity's greatest engineering achievements. Consider what this means. A spacecraft launched in 1977, built with technology decades removed from our current capabilities, still functioning, still sending information home, still operating in the extreme environment of deep space. It is a testament to the ingenuity of those who designed and built Voyager 1. Communication with Earth from such distances presents extraordinary challenges. Voyager 1's communication with Earth is limited by the fundamental laws of physics themselves. Signals travel at the speed of light, and even at this ultimate velocity, the electromagnetic waves carrying information from Voyager 1 take over 22 hours to travel one way from the spacecraft to Earth. This means that the controllers on Earth, when they receive a signal from Voyager 1, are receiving data from a time more than a day in the past. A conversation between Earth and Voyager 1 would involve a round trip of over 44 hours of waiting. The data rate at which information flows from Voyager 1 is remarkably low, around 160 bits per second. To put this in perspective, this is slower than the modems that connected computers in the 1990s. Yet through this gossamer thread of communication, we receive the scientific discoveries of this remarkable explorer. Every measurement, every observation must be compressed and transmitted through this narrow bandwidth, then amplified by some of the most powerful receivers on Earth to be comprehensible at all. The spacecraft's trajectory, calculated decades ago, was designed with two primary objectives in mind. First, to minimize fuel usage, preserving the precious hydrazine that would power the thrusters that could adjust the spacecraft's course. Second, to maximize scientific return from its planetary encounters. Every kilogram of fuel mattered. Every meter per second of velocity was precious. The scientists and engineers who designed this mission had to think with absolute clarity about every aspect of the journey. Today, Voyager 1 is not aimed at any specific star. Its path through the cosmos is not a directed arrow toward a particular destination. Yet mathematics and astronomy tell us that it will pass near the star Gliese, 445, in approximately 40,000 years. This star, currently too distant to see clearly with our telescopes, will one day become Voyager 1's closest neighbor, though at a distance still far too great for our current understanding of interstellar travel. The trajectory of Voyager 1 is not immune to the universe. It is influenced by the gravity of the Sun and of other stars, pulled this way and that by the invisible forces that bind all massive objects together. Its path curves slightly under the influence of stellar gravitation, a reminder that even in the vast emptiness of space, nothing travels in a perfectly straight line. Segment 3. The Inner Planets Farewell. Before Voyager 1 reached the outer planets that were its true destination, it had to pass through the inner solar system. This region, home to Mercury, Venus, Earth, and Mars, represents the realm of smaller worlds orbiting close to the Sun. As Voyager 1 passed through this inner region, it was moving toward the grand encounters that awaited, toward Jupiter and Saturn, toward the discoveries that would reshape our understanding of the solar system. The journey toward Jupiter took time, months of travel through the dark void of space, and then at last the great planet appeared. Jupiter, the gas giant, the king of planets, is a world of incredible complexity and power. When Voyager 1 approached this massive sphere of swirling clouds and storms, the spacecraft's instruments began to reveal secrets that had been hidden since the formation of our solar system. The discoveries at Jupiter were immediate and profound. Voyager 1 discovered a thin ring around Jupiter, a delicate structure of particles orbiting the massive planet. This ring had never been detected from Earth. Its discovery demonstrated the power of close-up exploration, of traveling to these distant worlds rather than merely observing them from afar. Additionally, Voyager 1 found 2 new Jovian moons, previously unknown to science. These celestial bodies, Thebe and Metis, joined the growing list of moons orbiting the giant planet. As Voyager 1 approached Jupiter, its cameras were constantly at work. The spacecraft took a picture every 96 seconds, creating a time-lapse movie of its approach to the massive planet. This sequence of images would reveal the dynamic nature of Jupiter's atmosphere, the constant motion and change within those swirling clouds. Scientists on Earth watched as this distant explorer drew closer and closer to the largest planet in our solar system. The images that Voyager 1 captured showed Jupiter's atmosphere to be more turbulent than during previous flybys. The storms were more violent, the colors more distinct, the patterns of atmospheric circulation more clear than ever before. These observations changed our understanding of how gas giant atmospheres function, revealing Jupiter to be a far more dynamic and active world than previously appreciated. The planet that had seemed stable was, in fact, constantly changing. As Voyager 1 completed its encounter with Jupiter, it was already setting its trajectory for the next great encounter. The spacecraft had been reprogrammed with new navigational parameters, new targets, new objectives. The data flowed back to Earth, and scientists began to analyze what they had learned. But Voyager 1, far out in space, was already moving toward its next destination, already on a path that would take it to the realm of Saturn, a planet that would provide even more extraordinary discoveries. The journey from Jupiter to Saturn would take nearly 2 more years. During this transit, the spacecraft continued to transmit data, continued to conduct scientific observations, continued its mission of exploration and discovery. The data stream was steady but slow, information flowing back across the solar system at the speed of light, carried by radio waves through the empty darkness of space. And then, at last, Saturn appeared, a world of rings, a planet unique in our solar system. Saturn is smaller than Jupiter, yet it is still a gas giant of tremendous size and complexity. But what makes Saturn unique is the magnificent ring system that surrounds it, a structure of millions upon millions of particles of ice and rock arranged in a delicate structure that has puzzled and fascinated humans for centuries. When Voyager 1 reached Saturn, the discoveries multiplied. The spacecraft found 5 new moons, 5 previously unknown celestial bodies orbiting the ringed planet. These discoveries expanded our understanding of how planetary systems form and evolve. Additionally, Voyager 1 discovered a new ring around Saturn, the G-ring, a delicate structure previously unknown. But perhaps the most significant target at Saturn was a particular moon, a world that had long fascinated scientists. This was Titan, a moon of unusual properties, a moon that appeared to have an atmosphere, something rare among the moons of our solar system. Voyager 1's trajectory had been optimized specifically for this close encounter, this moment that would reveal the secrets of this mysterious world. Segment 4. The Mystery of Titan. Titan had long captured the imagination of scientists. It was known that this moon of Saturn had an atmosphere, but the nature of that atmosphere, what lay beneath the clouds, what kind of world this actually was, all of this remained mysterious. As Voyager 1 approached, questions filled the minds of researchers on Earth. What would this distant explorer reveal? When Voyager 1 flew past Titan, its cameras captured remarkable images. But these images revealed something unexpected, something that challenged the scientists' expectations. Voyager 1's images of Titan showed a thick atmosphere that completely hid the surface. There would be no clear view of Titan's landscape, no photographs of whatever terrain lay beneath those clouds. Instead, the moon appeared as an orange sphere, featureless, from the perspective of Voyager 1's cameras. Yet even though the surface was hidden, the composition of the atmosphere could be analyzed. Spectroscopic analysis revealed that Titan's atmosphere is composed of 90% nitrogen. Nitrogen, the element that makes up most of Earth's atmosphere, is the dominant component of Titan's air. This discovery was profound. Here was a moon orbiting Saturn billions of kilometers from Earth, with an atmosphere fundamentally similar to our own in its basic composition. But there was more. Alongside the nitrogen, Voyager 1 detected methane and more complex hydrocarbons. These organic compounds suggested something remarkable. The conditions on Titan might allow for prebiotic chemical reactions, the kind of chemical processes that could lead to the development of life. Here was a world that, despite its extreme cold and distance from the sun, might have the chemistry of life itself. The discovery of these complex hydrocarbons on Titan opened entirely new fields of scientific inquiry. If methane and other organic compounds could exist on Titan, what other chemistry might occur in that thick atmosphere? What reactions might take place in the liquid that scientists theorized might exist on Titan's surface? The moon transformed from an abstract point of light into a world of genuine scientific interest, a place where perhaps the building blocks of life could be found. The trajectory of Voyager 1 toward Titan was precise. The spacecraft's trajectory was designed to maximize the scientific return from its Titan flyby, ensuring that Voyager 1 would pass close enough to gather detailed data while still maintaining the spacecraft's structural integrity and the safety of its instruments. This balance between scientific gain and practical necessity had to be carefully calculated. The approach to Titan took the spacecraft on an unusual path. The spacecraft's trajectory took it below the south pole of Saturn and out of the plane of the ecliptic. This decision had profound implications. By being directed below Saturn's south pole, Voyager 1's path would carry it away from the Sun's orbital plane, away from the region of space where all the planets align. This unusual trajectory meant one thing with certainty. Voyager 1's planetary science mission would end after Saturn. This was not a failure or a disappointment. It was in fact the planned conclusion to the first phase of Voyager 1's mission. The gravitational influence of Saturn, carefully calculated and planned for, would bend Voyager 1's path, accelerating it and flinging it out of the plane of the solar system. Voyager 1's trajectory ended its planetary science mission after its Saturn flyby, but in doing so, it opened the door to an entirely new mission, a new phase of exploration that no one at the time could have fully anticipated. As Voyager 1 completed its Saturn encounter and began to move away from the gas giant, it was already on course for its next destination. But this destination was not another planet. It was a realm even more distant, even more mysterious. It was the boundary of the sun's influence, the frontier where the solar wind gives way to the interstellar medium. It was the Heliopause, the barrier between our star's domain and the greater galaxy beyond. The passage of Voyager 1 past Saturn and Titan marked a turning point not just in the mission, but in human understanding of the solar system. The planets had been explored, their moons had been revealed. The detailed knowledge that scientists could now possess about these distant worlds was unprecedented. Voyager 1, having accomplished its primary mission with extraordinary success, prepared for a new journey, a voyage into the true wilderness of space, toward destinations and discoveries that would take decades to unfold. Segment 5. The long journey outward. After passing Saturn and Titan, Voyager 1 was flung outward into the solar system on a trajectory that would take it farther and farther from the Sun. The years passed. 1 year became 10, 10 became 20. The spacecraft continued its journey, its thrusters occasionally fired for minor course corrections, its instruments still gathering data, its radioisotope generators still producing electricity from the gentle decay of radioactive material. The spacecraft moved through the outer regions of the solar system, through a realm where the sun appeared as merely the brightest star in the sky, rather than the dominating presence it is near Earth. Here, in these outer regions, the solar wind, the stream of charged particles flowing from the sun, gradually weakened. The intensity of radiation from the sun diminished. The gravitational pull of our star, while still present, was less dominant. Yet Voyager 1 was not traveling through empty space. The solar wind, though diminishing, still permeated this region. The sun's magnetic field, though weaker, still extended outward. The heliosphere, that sphere of solar influence, surrounded the spacecraft. But as Voyager 1 traveled ever farther, the question that scientists asked became more pressing. Where does the heliosphere end? Where is that boundary between the realm of the sun and the realm of the galaxy? This region between the planetary orbits and the Heliopause is not a region of emptiness and sterility. It is filled with phenomena and objects of great interest. Comets occasionally pass through this region, visitors from the distant Oort cloud that surrounds our solar system. Dust particles drift through the void. Solar particles, ejected from the sun in various processes, slowly extend outward. The space environment is complex and dynamic, influenced by the constant outflow of solar energy and matter. The journey was long, covering vast distances that challenge human comprehension. Voyager 1, traveling at about 17 kilometers per second, was moving remarkably fast by human standards, yet in the cosmic scale, this is a slow and patient journey. The distances it had to cross to reach the Heliopause were so great that the journey would take decades. The spacecraft's instruments continued to gather data throughout this journey. The plasma detectors continued to measure the solar wind and the charged particles of interstellar origin. The magnetometer continued to map the solar magnetic field. The cosmic ray detectors continued to count the rare but energetic particles that penetrated through the solar system. This data was transmitted back to Earth in a constant stream, a thin thread of communication spanning billions of kilometers. Meanwhile, on Earth, decades were passing. The world that Voyager 1 had left behind in 1977 was changing. New technologies were being developed. New generations of humans were being born. The nations of the world continued their existence, their conflicts, their progress. Yet Voyager 1, far away in the darkness of space, continued its mission unchanged, unaware of the world's transformations, simply following the path that had been set for it so many years before. The spacecraft's power output was gradually diminishing. The radioisotope generators, while producing electricity through the decay of radioactive material, were gradually cooling. The output would never return to its original levels. Year by year, the available power decreased slightly. Scientists had to make choices about which instruments to keep powered and which to shut down. The infrared spectrometer was shut down. Other non-essential systems were deactivated. Resources had to be managed carefully. Yet even with diminishing power, Voyager 1 continued to send data home. The rate of data transmission, never high to begin with, became even slower as power had to be carefully rationed. But the flow of information continued. The spacecraft was still alive, still functioning, still in communication with its creators. The engineers and scientists who had built Voyager 1, who had designed it to last perhaps 5 to 10 years, were witnessing something extraordinary. A spacecraft that had outlived all expectations, that had far exceeded its original design specifications. The very existence of Voyager 1, continuing to function for decades beyond what had been anticipated, was itself a kind of success. The engineers who had worked on the spacecraft, many of whom were now elderly or had passed away, would have been amazed by this achievement. They had built well. They had designed a machine capable of enduring, capable of exploring, capable of sending knowledge back across the vast distances of space. Segment 6. The approach to the unknown. In the late 2000s and early 2010s, scientists became increasingly focused on a single question. When would Voyager 1 reach the Heliopause? When would it cross that boundary from the realm of the sun to the realm of the stars? The data that the spacecraft was sending suggested that this moment was approaching. The solar wind seemed to be getting weaker. The cosmic radiation seemed to be increasing. The boundary that Voyager 1 was approaching is called the Heliopause. This is the point where the influence of the sun's radiation is weaker than that of the interstellar medium, the vast ocean of material that fills the space between stars. But what exactly is this boundary? How defined is it? Is it a sharp line, a wall that the spacecraft crosses instantaneously, or is it a gradual transition, a zone of increasing width? Scientists discussed these questions. Theorists created models. Physicists calculated what the conditions might be at the Heliopause. But theory, no matter how carefully constructed, cannot compare to actual observation. Only Voyager 1, traveling through this region, could provide the data that would answer these fundamental questions. And the spacecraft, unknowingly, was approaching that moment when it would penetrate this barrier between solar system and galaxy. The measurements that Voyager 1 was taking became increasingly important. Every data point, every observation was scrutinized by scientists looking for signs of change, for evidence that the heliopause was near. The cosmic ray detectors were particularly important. As the spacecraft moved closer to the heliopause, the number of cosmic rays it encountered would increase. These high-energy particles, generated in supernova explosions and other violent events in the galaxy, were more common in interstellar space than they were within the sheltered environment of the heliosphere. The solar wind measurements were also crucial. Within the heliosphere, the solar wind is relatively strong. It is a steady stream of particles flowing outward from the Sun. But as one approaches the heliopause, the solar wind should begin to decrease. The two flows, the outward solar wind and the inward pressure of the interstellar medium, should become increasingly balanced. In the year 2012, a remarkable event was beginning to unfold. Voyager 1 was sending back data that suggested that something significant was happening. The cosmic ray counts were rising. The solar wind measurements were becoming unusual. The magnetometer was detecting changes in the solar magnetic field. Scientists watched these trends with great interest, aware that they might be witnessing a historic moment. The data continued to accumulate. Week after week, month after month, the information flowed back from the distant spacecraft. But remember, signals from Voyager 1 take over 22 hours to reach Earth. When scientists received data dated August 15th, they were actually looking at measurements from a day in the past. When they received information from August 20th, they were viewing events that had occurred more than a day earlier. This time delay meant that Voyager 1 had already crossed the heliopause before scientists on Earth became fully aware of what was happening. The spacecraft had passed through this momentous boundary in early August, but it would take days for the evidence to be transmitted back to Earth, analyzed and confirmed. By the time scientists were certain that Voyager 1 had crossed the heliopause, the crossing had already occurred, already become history. The significance of this moment cannot be overstated. Voyager 1 was about to become the first human-made object to enter interstellar space. No spacecraft, no probe, no mechanical creation of humanity had ever ventured beyond the heliosphere before. The boundary that Voyager 1 was approaching was the greatest frontier that human technology had ever reached. Once crossed, Voyager 1 would be truly beyond the Sun's realm, truly in the galaxy at large. Segment 7, Crossing the Threshold, August 25th, 2012. This date would become historic in the annals of space exploration. On this date, Voyager 1 crossed the heliopause and entered interstellar space. The boundary that had been approached so carefully, calculated so precisely, studied so intently, was finally crossed. Voyager 1 had reached the frontier. The crossing was not announced immediately. Scientists carefully studied the data before making any announcements. They wanted to be absolutely certain. The evidence had to be clear, unambiguous, definitive. The data they examined showed multiple converging lines of evidence, all pointing to the same conclusion. Voyager 1 had crossed the heliopause. Voyager 1's crossing of the heliopause was confirmed by changes in plasma levels and cosmic radiation. The data showed exactly what scientists had predicted would happen. The low-energy particles from the Sun, the solar wind particles that had always been present in Voyager 1's detectors, suddenly began to decrease. The cosmic rays, the high-energy particles from beyond the heliosphere, began to increase sharply. The spacecraft detected a steady rise in collisions with high-energy particles above 70 mega-electron volts, thought to be cosmic rays from supernovae. These cosmic rays are generated in the tremendous violence of stellar explosions, in the death throes of stars at the end of their lives. Some of these particles had been traveling through the galaxy for millions of years, only to be detected at last by Voyager 1's sensitive instruments. At the same time that the cosmic ray flux increased, there was a dramatic drop in collisions with low-energy particles from the Sun. The solar wind, that constant breeze of particles flowing from our star, had been a feature of every measurement that Voyager 1 had ever made. Now suddenly it was gone. The change was stark, definitive, unambiguous. Voyager 1 had crossed from the solar wind into a region where the solar wind no longer dominated. Scientists announced their discovery with appropriate gravity and wonder. Voyager 1's crossing of the Heliopause was a major milestone in space exploration. The media picked up the story. News outlets around the world reported that humanity had sent an explorer beyond the realm of its home star, into the greater galaxy. The achievement was celebrated. The accomplishment was recognized as historic. Voyager 1's crossing of the Heliopause was the first time a human-made object had entered interstellar space. No machine built by human hands had ever gone this far. No robot, no probe, no piece of human engineering had ever ventured beyond the heliosphere before. Voyager 1 was alone in this achievement, unique in this distinction. It had become the ambassador of Earth to the galaxy at large. The confirmation of the crossing came from multiple sources of data. Voyager 1's crossing of the Heliopause was confirmed by a sharp increase in cosmic ray collisions in late August 2012. But the evidence extended beyond this single observation. The spacecraft's crossing of the Heliopause was also confirmed by a dramatic drop in solar wind particles. The two types of evidence, different in nature, yet both pointing to the same conclusion, provided the certainty that scientists required. The moment of crossing was celebrated by Voyager 1's team, by NASA, by the scientific community. Yet Voyager 1 itself, billions of kilometers away, was unaware of the celebration. The spacecraft continued its quiet journey, following the path that had been set for it decades before. It continued to gather data, continued to transmit information, continued its mission of exploration in the vast darkness of space. Voyager 1's crossing of the Heliopause was a major scientific achievement. It represented the culmination of 35 years of exploration, of survival against tremendous odds, of continued function despite the harsh environment and the demands of space travel. It represented human innovation, human determination, human curiosity, reaching out to touch the greater universe. The Heliopause itself is more than a simple boundary. It is a complex region of interaction between the solar wind and the interstellar medium. It is not a sharp line, but rather a zone of transition. It is influenced by the flow of particles, by magnetic fields, by the energies involved in the meeting of two different populations of charged particles. Understanding this boundary, through Voyager 1's measurements, would teach scientists about how stars interact with the greater galaxy, how the solar system fits into the cosmos. Segment 8. The Interstellar Environment. After crossing the Heliopause, Voyager 1 entered a realm that was unknown in detail, a region that had never been directly explored. The interstellar medium, that vast ocean of material that fills the space between stars, stretched out in all directions around the distant spacecraft. This was a region of genuine discovery, of genuine exploration into the unknown. Voyager 1 is now 40 astronomical units beyond the Heliopause. An astronomical unit is the distance from Earth to the Sun, approximately 150 million kilometers. 40 times this distance, Voyager 1 travels through the interstellar medium, gathering data, sending information home, revealing the nature of space beyond the solar system's sheltering influence. What Voyager 1 has revealed about the interstellar medium has surprised and astonished scientists. The interstellar medium, as measured by Voyager 1, is much more influenced by the heliosphere than previously thought. The Sun's realm does not end sharply at the Heliopause. Instead, it influences the space around it, affecting the interstellar medium in ways that theory had not fully anticipated. The heliosphere is not simply a bubble sitting in the interstellar medium. It is an active, dynamic region of interaction. Scientists had expected the interstellar medium to be a relatively quiet and stable environment, at least on the scales of human observation. But what Voyager 1 has revealed contradicts this expectation. The interstellar medium is not quiet. It is agitated and influenced by the Sun. The outflow of solar wind and the solar magnetic field extend far beyond the Heliopause, affecting the particles and fields in the surrounding space. The heliosphere is much larger than had been anticipated. To understand this region more fully, one must consider what constitutes the interstellar medium. The space between stars is not truly empty. It is filled with particles and dust, with magnetic fields and radiation. The interstellar medium is filled with denser plasma from the explosion of giant stars millions of years before. These stellar explosions occurred long ago, before the solar system even formed, yet their effects persist today in the plasma and dust of the interstellar medium. The interstellar medium is influenced by the Sun's magnetic field and solar wind. The solar magnetic field, which originates in the processes of the Sun itself, extends outward from our star for vast distances. This field influences the motion of charged particles in the interstellar medium. The solar wind, the flow of particles from the Sun, also influences the surrounding space. The boundary between solar influence and galactic influence is not sharp, but gradual. Beyond the direct influences of the Sun, the interstellar medium has its own character and structure. The interstellar medium is filled with cosmic rays from supernovae and other sources. These high-energy particles, generated in the violent deaths of stars and in other energetic events throughout the galaxy, fill all of space. They carry information about the processes occurring in the galaxy, about the violence and energy of stellar death, about the nature of space at the highest energies. The interstellar medium is not uniform, it is structured and dynamic. In some regions, the density of particles is higher, In others, it is lower. Some regions are warm, others are cold. Some regions are ionized, with electrons separated from atoms. Others are neutral. The interstellar medium is a complex environment, changing from place to place and from time to time. Voyager 1's measurements of the interstellar medium are helping scientists understand the structure and dynamics of the heliosphere. By measuring what exists in the interstellar medium, scientists can better understand how the heliosphere fits into the larger cosmic environment. By understanding the pressure from the interstellar medium, they can better comprehend how the solar wind creates a boundary, how the Sun carves out a region of influence in the galaxy. Voyager 1's measurements of the interstellar medium are also helping scientists understand the influence of the Sun's magnetic field and solar wind on the surrounding galaxy. The solar wind does not simply end at the heliopause. It extends beyond, affecting and influencing the space in the solar neighborhood. The solar magnetic field creates structures in space, creates density variations, creates complexity in what might have seemed a simple or uniform region. The journey of Voyager 1 through the interstellar medium is continuing. With each passing year, the spacecraft moves farther and farther from the Sun, deeper and deeper into the true wilderness of the galaxy. The data continues to flow, revealing new information about this region of space, about the boundary between solar system and galaxy, about the nature of our cosmic neighborhood. Segment 9: Subtle Discoveries and Magnetic Mysteries. As Voyager 1 continued its journey through the interstellar medium, the scientists on Earth who monitored its data were constantly looking for new discoveries, new patterns, new phenomena. The spacecraft's instruments, though designed for a mission lasting merely 5 to 10 years, were still functioning, still gathering data, still revealing secrets about space. One of the significant discoveries made by Voyager 1 as it traveled through the interstellar medium was unexpected. Voyager 1 discovered a region of magnetic bubbles in the interstellar medium. These structures, previously unknown, suggested that the interstellar medium was more complex and structured than had been anticipated. Magnetic bubbles, regions where the magnetic field has unusual properties or concentrations, indicate the presence of forces and phenomena not fully understood before Voyager 1's observations. These magnetic bubbles are thought to be remnants of ancient stellar explosions, structures created by supernovae that occurred long ago. They represent pockets of organized magnetic field within the larger, more chaotic interstellar medium. Their discovery added to the growing realization that the interstellar medium, far from being simple or uniform, is actually quite complex and structured. But Voyager 1's discoveries were not limited to new structures. The spacecraft also made observations that contradicted expectations. Voyager 1 found no indication of an expected shift in the solar magnetic field. Scientists had predicted that as Voyager 1 crossed the heliopause, there would be a specific change in the direction or strength of the solar magnetic field. This expected shift did not occur, or at least not in the way that had been predicted. This discovery, or rather the absence of an expected discovery, was important. It suggested that the solar magnetic field's behavior at the heliopause is more complex than theories had suggested. The transition from solar-influenced space to galactic space is not as sharp or as simple as had been theorized. The magnetic field does not simply reverse direction or change strength in a clear, definitive manner. Instead, the change is more subtle, more gradual, more complex. The implications of this discovery rippled through the scientific community. New theoretical models had to be developed. New hypotheses had to be tested. The simple picture of the heliosphere as a spherical bubble with a sharp boundary had to be refined and complicated to account for what Voyager 1 actually observed. The measurements that Voyager 1 continued to make in the interstellar medium were crucial for understanding these phenomena. Every data point, every observation, every measurement contributed to a growing picture of this region of space. Slowly, carefully, scientists were building a more accurate model of how the heliosphere actually behaves, how it influences and is influenced by the interstellar medium. The spacecraft continued to travel and continued to send back data. The data rate was low, the power available was decreasing, the instruments were aging. Yet still, Voyager 1 functioned and transmitted. The scientists who operated the spacecraft had become very skilled at extracting maximum information from minimal data. They had learned to interpret signals that were barely above the noise of the receiver, to coax meaningful information from a data stream that was limited to mere bits per second. One must consider the incredible patience and precision required to operate such a spacecraft. Every command had to be carefully calculated. Every instruction to the spacecraft had to be transmitted across billions of kilometers, arriving at Voyager one after many hours of travel at the speed of light. The responses, the confirmations, the data all had to travel back across the same vast distance. The controllers on Earth, when they sent a command to Voyager 1, could not expect a response for more than a day. The operation of this spacecraft was an exercise in patience and precision. Yet despite these challenges, the work continued. Scientists analyzed the data, theories were developed and refined, papers were published in scientific journals, conferences were held where scientists discussed Voyager 1's findings. The work of the spacecraft, though conducted silently in the darkness of space, influenced human understanding of the universe. Segment 10. The plasma around us. The interstellar medium, this vast ocean of material that surrounds the solar system, is primarily composed of plasma. Plasma is a state of matter where electrons have been separated from atoms, creating a fluid of charged particles. This state is common throughout the universe, though it was not well understood until relatively recently in human history. The Sun itself is made of plasma. The solar wind consists of plasma. The interstellar medium is largely plasma. Voyager 1's plasma detectors, instruments designed to measure the properties of charged particles in space, have been crucial in understanding the nature of the environment through which the spacecraft travels. These detectors measure the speed, direction, energy, and composition of plasma particles. They measure the density of the plasma, the number of particles in a given volume. They measure the temperature, which is related to the average energy of the particles. The ambient space environment beyond the heliopause is filled with low-density plasma and cosmic rays. This characterization, while simple, encompasses a complex reality. The plasma that Voyager 1 measures beyond the heliopause is different from the solar wind plasma that existed within the heliosphere. The sources are different, the temperatures are different, the compositions are different. The ambient space environment is influenced by the Sun's magnetic field and solar wind. Even at a distance of over 100 billion kilometers from the Sun, the influence of our home star is still detectable. The solar magnetic field, frozen into the solar wind, extends this far. The solar wind, though diminished compared to its intensity near the Sun, still carries particles and energy at Voyager 1's location. This realization that the heliosphere extends so far is in itself a major discovery. The solar system is larger than had been thought. The region of space directly influenced by our Sun is more extensive than theory had predicted. Voyager 1, by traveling through this region and measuring its properties, has revealed the true size and structure of the heliosphere. The ambient space environment is filled with cosmic rays from supernovae and other sources. These high-energy particles, though rare compared to the lower-energy particles of the plasma, are nonetheless important and scientifically interesting. A single cosmic ray particle carries tremendous energy, energy that no particle from the solar wind could match. These cosmic rays originated in events of tremendous violence and energy, in the deaths of massive stars, in the collisions and interactions of objects in space. The ambient space environment is not uniform, it is structured and dynamic. The density of particles varies from place to place. The intensity of the magnetic field varies. The number of cosmic rays varies. The space around the solar system is not a featureless void, but a region of texture and variation, of local structures and global patterns. When one considers the plasma environment of the solar neighborhood, one must remember that the Sun itself is just one star among billions in our galaxy. Each star, like the Sun, has its own heliosphere, its own region of influence. These heliospheres interact with each other and with the interstellar medium. The solar neighborhood is a region where multiple stellar influences meet and interact. The structure of this region, the density of particles, the magnetic field configurations, all result from the interplay of these various influences. Voyager 1, by traveling through this region and measuring its properties, is providing data about not just our solar system, but about the general structure of the galaxy. The measurements made by Voyager 1 can be compared with theoretical models. These models can be tested and refined based on Voyager 1's data. The knowledge gained extends beyond our immediate cosmic neighborhood to general principles about how stars interact with the interstellar medium. Segment 11. The Golden Message continues its journey. As Voyager 1 continues its long journey through the interstellar medium, there is something aboard the spacecraft that has captured the imagination of humanity as nothing else has. The Golden Record, that time capsule of Earth, continues its voyage through space. No one has yet found it. No extraterrestrial intelligence has yet encountered it. Yet it remains aboard, continuing its journey, carrying its message into the far future. The Golden Record is not merely a physical object, though it is that. It is a symbol, a representation, a time capsule created with care and thoughtfulness. The Golden Record includes greetings in 55 languages, each one a voice from Earth, each one a representation of human civilization in 1977. These greetings speak of peace, of welcome, of hope that whoever finds this message will understand that we were here, that we existed, that we reached out. The Golden Record includes music from different cultures: classical music from Europe, jazz from America, folk music from Africa, Asia, and other regions of the world. The music was selected to represent the diversity of human culture, the variety of ways that humans express themselves artistically. A listener encountering this music would understand something about human creativity, about human emotion, about the ways that humans use sound to convey feeling and meaning. The Golden Record includes images of Earth and its life forms, photographs of landscapes, of people, of animals, of plants, images showing the diversity of life on our planet, images showing the works of human civilization, the buildings and structures that humans have created, images attempting to convey what Earth is, what humanity is, what the diversity of life on our world encompasses. The Golden Record is intended to communicate the story of humanity to any extraterrestrial intelligence that might find it. It is a message sent into the future, intended for a recipient unknown. It assumes that someday, somewhere, another intelligent species might discover Voyager 1. It assumes that this species would have the knowledge and capability to understand what the record is, how to play it, how to interpret its contents. It assumes, ultimately, that the message will be understood. The Golden Record is made of gold-plated copper. This material was chosen for its durability and its resistance to corrosion. Unlike other metals that might rust or degrade over time, gold and copper can resist the effects of time and environment. The gold plating provides an outer layer of protection, while the copper underneath provides structural support. The choice of materials reflects the desire to create something that could last for billions of years, something that could survive the journey through space. The Golden Record is designed to last for billions of years. This timescale is almost incomprehensible to human minds. 1 billion years is 1,000 times longer than humanity has existed. It is longer than the entire history of life on Earth. Yet the creators of the Golden Record designed it with this timescale in mind, wanting the message to persist, to endure, to remain intact for periods of time far exceeding anything in human experience. The Golden Record is intended to be a message in a bottle from Earth. A message in a bottle is a romantic concept, a symbol of communication sent out to sea with hope that it will reach an unknown recipient. The Golden Record, sent out into the ocean of space, serves the same symbolic function. It is a message sent from our world with hope that it will someday reach another world, another intelligence, another consciousness. The Golden Record is intended to represent the diversity of life on Earth, not just human life, but all life. The record contains sounds of nature, sounds of animals, sounds of the planet itself. A listener to the record would understand something about the biological richness of Earth, about the varieties of life forms that share our world, about the interconnectedness of all life. The Golden Record is intended to inspire wonder and curiosity in any beings that encounter it. The creators of the record understood that if an alien intelligence found Voyager 1, that intelligence would be far from home, far from their own world, just as Voyager 1 is far from Earth. The record is an attempt to communicate something about who we are, what we value, what we felt was important enough to send out into space as a representation of humanity. Segment 12. Communication across the void. The relationship between Voyager 1 and Earth is defined by communication, by signals traveling through space at the speed of light, carrying information across vast distances. This communication is what keeps Voyager 1 alive in a sense. The commands from Earth tell the spacecraft which instruments to keep powered, which to shut down. The data from Voyager 1 tells Earth what the spacecraft is experiencing, what it is discovering, what it is measuring. Yet this communication is limited, constrained by the laws of physics itself. Voyager 1's communication with Earth is limited by the speed of light, with signals taking over 22 hours to travel one way from Voyager 1 to Earth. This means that a real-time conversation is impossible. Questions asked by scientists on Earth take over 22 hours to reach the spacecraft. Answers, if the spacecraft must perform some action and then report back, take another day or more to return. This time delay has profound implications for how Voyager 1 is operated. The spacecraft cannot be controlled in real time. It cannot be given commands and immediately respond to the results of those commands. Instead, the spacecraft must largely operate autonomously, following programs that were written and uploaded to its computers years or decades ago. The spacecraft is, in a very real sense, on its own, far from home, carrying out a mission that was planned long ago. Voyager 1's communication with Earth is limited by the spacecraft's power and antenna design. The high-gain antenna that transmits data back to Earth is pointed toward Earth, but the spacecraft is so far away that the antenna's signal by the time it reaches Earth is incredibly weak. The signal is measured in watts, a unit of power, but the amount of power reaching the Earth's receiving stations is smaller than the power consumed by a Christmas light. Yet the most sensitive radio receivers in the world can still detect this signal, still extract information from it. Voyager 1's communication with Earth is limited by the spacecraft's trajectory and distance. The farther away Voyager 1 becomes, the weaker its signal becomes. The signal strength drops in proportion to the square of the distance. As Voyager 1 continues to travel away from Earth, this signal will become progressively weaker. At some point, if the spacecraft continues its journey long enough, even the most sensitive receivers on Earth will no longer be able to detect the signal. The communication will cease, not because of a failure on Voyager 1, but simply because the signal will be too weak to detect. This reality colors all considerations about Voyager 1's future. Every year the signal becomes a little bit weaker. Every year, the available power on the spacecraft decreases a little bit. Scientists know that at some point the mission will have to end. The spacecraft cannot communicate forever. The power cannot last forever. Yet the goal is to extend the mission as long as possible, to extract as much scientific knowledge as is possible, to keep Voyager 1 alive and communicating for as long as is feasible. The spacecraft's data rate is very low, about 160 bits per second. To understand what this means, consider that modern high-speed internet connections operate at gigabits per second, millions of times faster than Voyager 1. Yet through this incredibly slow data rate, tremendous amounts of information have been conveyed. Scientists have learned to compress data, to prioritize measurements, to extract maximum information from minimal bandwidth. The techniques used to operate Voyager 1 have advanced significantly since the spacecraft was launched. The data that comes from Voyager 1 is first received by large radio telescopes on Earth, instruments that are sensitive enough to detect the incredibly weak signals from space. The signals are then decoded, analyzed, and stored. Scientists around the world can then access this data, can analyze it, can publish papers about its findings. The data from Voyager 1 has become a global resource, available to scientists everywhere who are interested in the results. Segment 13. The Legacy of Instruments and Discoveries. The instruments that Voyager 1 carries have become legendary in the history of space exploration. These instruments, many of them now over 4 decades old, continue to function and provide data about the environment through which the spacecraft travels. Each instrument was designed with care, built with precision, and maintained against tremendous odds. Voyager 1's instruments include cameras, spectrometers, and plasma detectors. The cameras, though no longer taking detailed images of planets, still function and can detect bright stars and other objects in space. The spectrometers, instruments that analyze the composition of materials by breaking their light into component wavelengths, still operate and provide crucial information about the plasma environment. The plasma detectors, the instruments that measure charged particles in space, remain the most actively used instruments on the spacecraft. The spacecraft's cameras were used to take images of Jupiter and Saturn during the planetary encounters. These cameras, which operated in visible light and in infrared wavelengths, captured the first detailed images of these distant planets. The images of Jupiter showed the great red spot and the dynamic nature of the Jovian atmosphere. The images of Saturn revealed the exquisite detail of the planet's ring system and its many moons. Voyager 1's spectrometers were used to analyze the composition of planetary atmospheres. At Jupiter, the spectrometers revealed the composition of the Jovian atmosphere, showing the presence of various chemical elements and compounds. At Saturn, particularly at Titan, the spectrometers revealed the composition of that moon's thick atmosphere, discovering the prevalence of nitrogen and the presence of complex organic compounds. The spacecraft's plasma detectors were used to study the solar wind and interstellar medium. These instruments have been particularly valuable in the interstellar phase of Voyager 1's mission, as they provide direct measurements of the particle environment through which the spacecraft travels. The plasma detectors measure the density, temperature, and composition of the plasma, providing crucial information about the nature of the interstellar medium. Voyager 1's instruments were designed to operate in the harsh environment of space. The instruments had to withstand the intense radiation of the outer solar system, the extreme cold of deep space, the vacuum of space itself. They had to function without human maintenance, without repair, in an environment where failure cannot be easily fixed. The engineering that went into these instruments was extraordinary. The spacecraft's instruments were powered by radioisotope thermoelectric generators. These remarkable devices convert the heat from decaying plutonium into electrical power. As the plutonium gradually decays, it releases heat, which the thermoelectric generators convert into electricity. This conversion is not perfectly efficient, but it is remarkably reliable. The radioisotope thermoelectric generators have kept the spacecraft powered for decades, a testament to the engineering of the power system. Voyager 1's instruments were designed to operate for decades. When the spacecraft was launched in 1977, the mission was expected to last 5 to 10 years. Yet the instruments, many of them original to the spacecraft, are still operating today over 40 years later. Some instruments have been shut down to conserve power, but many continue to function and provide data. The spacecraft's instruments were designed to operate in the low-temperature environment of deep space. Where Earth is warmed by the sun, the outer regions of space are incredibly cold. Temperatures in the interstellar medium are measured in kelvins, just a few degrees above absolute zero. The instruments had to be designed to function in this extremely cold environment, where materials become brittle and lubricants freeze solid. Voyager 1's instruments were designed to operate in the high radiation environment of the outer solar system. The radiation belts of Jupiter are intense, a challenging environment for any spacecraft. The cosmic radiation of interstellar space is also significant, though less intense than the Jovian radiation. The instruments had to be designed to function despite this radiation, to be shielded against its effects where possible, and to degrade gracefully as radiation damaged their components. The spacecraft's instruments were designed to operate in the vacuum of space. The vacuum of space is unlike anything found on Earth. It is not merely the absence of air, but an environment where the normal assumptions about pressure, temperature, and matter no longer apply. Instruments designed for Earth's atmosphere would not function in this environment. Every aspect of Voyager 1's instruments had to be designed with the vacuum of space in mind. Segment 14. The Continuing Journey and Future Prospects. Voyager 1 continues its journey through the interstellar medium, moving ever farther from the Sun with each passing year. The spacecraft travels at approximately 17 kilometers per second, moving outward at a rate of about 3.5 astronomical units per year. At this rate, it would take Voyager 1 approximately 40,000 years to pass near the star Gliese 445, the nearest star in its path. This timescale, 40,000 years, exceeds the entire span of recorded human history. Recorded history, the period during which humans have written records of their activities and thoughts, spans only about 5,000 years. 40,000 years extends far back into the prehistoric past, to a time when modern humans were just beginning to spread across the Earth. Yet this time scale, incomprehensible as it is the time scale on which Voyager 1 travels. The trajectory of Voyager 1 is not aimed at any specific star. The spacecraft is not being directed toward Gliese 445. Rather, Gliese 445 simply happens to lie in the direction that Voyager 1 travels, and in approximately 40,000 years, the spacecraft will pass relatively close to this star. The encounter will occur not through intentional design, but through the mathematical intersection of the spacecraft's path with the location of the star. The spacecraft's trajectory is influenced by the gravity of the Sun and other stars. Though the Sun's gravity is now much weaker at Voyager 1's location than it was when the spacecraft was near the planets, it still exerts an influence. The Sun's gravity gently curves the spacecraft's path. The gravity of distant stars also influences the trajectory, though their effects are extremely slight given the vast distances involved. The path of Voyager 1, though it appears to be a straight line on the timescale of human observation, is actually curved by these gravitational influences. Voyager 1's trajectory is calculated to minimize fuel use and maximize scientific return. This principle has guided the trajectory design since the mission's beginning. Every meter per second of velocity, every degree of angle in the trajectory was carefully calculated to ensure that the spacecraft could reach its scientific objectives while using the minimum amount of fuel. Decades of operation have validated the wisdom of these calculations. The spacecraft has achieved its objectives and continues to return scientific data. As for the future, predictions must be made with care. Voyager 1 is expected to continue sending scientific data until at least 2025. This means that if all systems continue to function, Voyager 1 should be able to return useful scientific measurements for at least several more years beyond the current date. The power situation, the crucial factor in determining mission duration, remains adequate for this time frame, assuming no unexpected failures occur. The spacecraft might send engineering data until 2036. Engineering data is less detailed than scientific data, consisting more of information about the spacecraft's health and status rather than measurements of the environment. This data would allow mission controllers to monitor the spacecraft's condition to ensure that it is still functioning as expected, to maintain contact with this distant explorer even as the instruments fall silent one by one. But beyond 2036, what will happen? The radioisotope thermoelectric generators will have decayed further. The available power will have diminished even more. At some point, the power supply will no longer be adequate to maintain even basic communications. The spacecraft will continue traveling, will continue following its trajectory through space, but it will no longer be able to send messages home. The voice of Voyager 1, silent at last, will continue its journey alone. Yet even in this silence, Voyager 1 will not be truly alone. The golden record continues aboard, its message preserved in the precious metal of its construction. The spacecraft itself, with all its remarkable instruments and engineering, continues its voyage. Voyager 1, silenced, powered down, will continue to travel through the cosmos for billions of years, the artifact of humanity drifting through the galaxy long after humanity itself, as it currently exists, has changed beyond recognition. This future, this distant time when Voyager 1 sends its last message to Earth, is not something to mourn, but something to appreciate. The spacecraft has far exceeded its original design specifications. It was meant to function for 5 to 10 years. It has functioned for over 40. It was meant to visit the outer planets. It has traveled beyond the reach of the Sun's influence. It was meant to be a probe. It has become a symbol of human achievement and aspiration. The story of Voyager 1 is a story of ambition, of engineering, of the human drive to explore and understand. It is a story of success against tremendous odds. It is a story that will continue silently as the spacecraft continues its journey through the cosmos. One day, billions of years from now, Voyager 1 might encounter a star or a planet. It might be captured by gravity and diverted from its path. It might be damaged by collision with some interstellar particle. Or it might continue forever, traveling through the empty space of the universe, silent and distant. A messenger from Earth carrying its message of peace and hope into the darkness. Segment 15. Reflections on distance and time. To truly understand Voyager 1, one must contemplate the vast scales with which it contends. The distances are beyond easy comprehension. The timescales are almost incomprehensible. Yet it is in contemplating these scales that one begins to understand the true achievement that Voyager 1 represents. The distance from Earth to Voyager 1 is so vast that light itself, traveling at the fastest speed known to exist, takes more than 22 hours to bridge the gap. A radio signal, traveling at the speed of light, is still the fastest possible means of communication. Yet even at this ultimate speed, a one-way journey takes more than a day. This means that the distance between Earth and Voyager 1 is approximately 20 billion kilometers, twice the distance from the Sun to Neptune, far beyond the orbit of the most distant known planet. Consider what this distance means. A jet airplane traveling at 900 kilometers per hour would take more than 2,000 years to cover this distance. A car traveling at 100 kilometers per hour would take 200,000 years. A walking human at 5 kilometers per hour would require 4 billion years. Light itself, the fastest thing in the universe, takes nearly a day to traverse this distance. The vast scale is almost incomprehensible. Yet Voyager 1 has covered this distance. It has traveled this far from home in the time that has passed since 1977. Future spacecraft might travel faster, might reach farther, might accomplish even more. But Voyager 1 was the first. It was the pioneer, the explorer, the forerunner of all future spacecraft that will venture into the interstellar medium. When future spacecraft eventually leave the solar system, when they eventually travel to other stars, Voyager 1 will still be there, having arrived first, still sending its whispered messages home. The time that Voyager 1 has been traveling is almost incomprehensible in a different way. 40 years, nearly half a century, from 1977 to 2017. More than 40 years of continuous operation. More than 40 years of data transmission. More than 40 years of exploration. During this time, the world on Earth has changed dramatically. Technologies that were cutting edge when Voyager 1 was launched have become obsolete. People who were alive when Voyager 1 left Earth have grown old or died. Generations of humans have lived their entire lives within the time span of Voyager 1's mission. Yet Voyager 1 continues. While human affairs move at the pace of human life, Voyager 1 moves at the pace of astronomy, the pace of the cosmos. A year to a human is a year, but to an astronomer contemplating the motion of planets and stars, a year is but an instant. Voyager 1, moving at its steady pace of 17 kilometers per second, advances through space at a rate that seems slow only because we measure it on human time scales. The power of Voyager 1 comes from radioactive decay, from the transformation of matter into energy. The plutonium in the spacecraft's thermoelectric generators decays slowly, yielding heat and particles as it transforms into lighter elements. This natural process, occurring at a rate fixed by the laws of physics, provides power at a decreasing rate. As the years pass, less and less heat is available, less and less power can be generated. Yet still, power flows, still the instruments function, still the spacecraft lives. This power source will ultimately determine the end of Voyager 1's mission. The power will diminish until there is no longer enough electricity to keep the transmitter active. The signal will fail. The spacecraft will become silent. Yet the spacecraft will continue its journey through space, powered by nothing but the gravity that guides its path. It will continue until some other force stops it, some star's gravity captures it, some collision alters its course, or it will continue forever, an eternal wanderer through space. Segment 16. The Wonder of Exploration and the Human Spirit. As we reflect on Voyager 1 and its extraordinary journey, we cannot help but contemplate what this achievement means for humanity. This spacecraft represents more than engineering and technology, though it is certainly that. It represents the human spirit, the human drive to explore, to understand, to push beyond known boundaries. The exploration of space is fundamentally rooted in human nature. Throughout history, humans have been explorers. We have crossed oceans, we have climbed mountains, we have ventured into deserts and jungles. We have looked at the horizon and wondered what lies beyond. This impulse, this drive to explore, is deep within human nature. It has motivated countless discoveries and adventures throughout human history. Voyager 1 represents the latest chapter in this age-old story of exploration. Where explorers once sailed across oceans in wooden ships, now we send spacecraft across the void of space. Where explorers once risked their lives in unknown lands, now machines explore on our behalf, returning knowledge to their creators. Yet the spirit is the same. The desire to know, to understand, to explore the unknown continues to drive human endeavor. The creation of Voyager 1 itself is a testament to what humans can accomplish when we work together toward a common goal. Thousands of engineers, scientists, technicians, and administrators work together to design, build, and launch this spacecraft. They solved problems that had never been solved before. They created technologies that were at the cutting edge of human capability. They built a machine that would, against all reasonable expectations, continue to function and provide data for over 40 years. This same spirit of cooperation and excellence continues to this day in the work of the Voyager team. A small but dedicated group of scientists and engineers continues to maintain contact with the spacecraft, to analyze its data, to ensure that it continues to function. They make decisions about which instruments to keep powered and which to shut down. They navigate the spacecraft through space, adjusting its trajectory when necessary. They are the keepers of Voyager 1, the guardians of this extraordinary mission. The data from Voyager 1 has fundamentally changed our understanding of the solar system and the cosmos. Before Voyager 1's encounters with Jupiter and Saturn, these planets were distant, mysterious objects. The moons of these planets were barely more than points of light through Earth-based telescopes. The rings of Saturn were a curious phenomenon without detailed understanding. Voyager 1 changed all of this. It revealed these worlds in unprecedented detail, transforming them from abstract concepts into real, tangible places with geology and atmosphere and weather. Beyond the planets, Voyager 1 has revealed the nature of the heliosphere and the interstellar medium. It has shown that the Sun's influence extends far farther than theory had predicted. It has shown that the boundary between solar system and galaxy is not sharp but gradual, a zone of complex interaction. It has shown that space itself, far from being empty and featureless, is complex and dynamic, full of structures and phenomena. The golden record, that time capsule aboard Voyager 1, represents something deeper than scientific measurement or data collection. It represents our desire to communicate, to reach out, to make contact with whatever other civilizations might exist in the cosmos. The record is, in a fundamental sense, an artifact of hope. It expresses the belief that somewhere, someday, someone might encounter our message and understand that we existed, that we were here, that we looked outward and wondered. Whether Voyager 1 will ever be found, whether the golden record will ever be played by an alien intelligence, is unknown and perhaps unknowable. The probability is vanishingly small. The distances are so vast, the timescales so long, that the chances of Voyager 1 encountering an inhabited world or a traveling civilization seem nearly zero. Yet we sent the record anyway. We sent the message anyway. We reached out into the darkness anyway, hoping that somehow, someday, it might be received. This action, sending a message with virtually no chance of being received, is perhaps the most human of all actions. It is an act of hope in the face of overwhelming odds. It is an act of faith that meaning and communication matter, regardless of the probability of success. It is an affirmation that who we are, what we value, and what we have created is worth preserving and sharing, even if that sharing might never occur. Segment 17. The Silence of the Cosmos and Eternal Voyage. As Voyager 1 continues its eternal journey through the interstellar medium, it moves through regions of space where it will almost certainly never encounter anything or anyone. The density of matter in the interstellar medium is incredibly low. The probability of collision with any object is vanishingly small. The probability of encountering another spacecraft, another probe, or an intelligent being is so low as to be virtually impossible on any timescale that humans can comprehend. Yet Voyager 1 continues, silent and steady, advancing through the darkness. Its instruments continue to gather data, sending what information they can back to Earth as long as power permits. But the spacecraft also carries with it, in the silence of its journey, something that cannot be transmitted, something that cannot be measured by instruments. It carries the hopes and dreams of humanity, the aspirations of the people who created it, the love of those who sent it forth into space. The silence of the cosmos is profound. There is no sound in space, no air to carry vibrations. There are no birds singing, no wind rustling through leaves, no people talking. There is only the faint crackle of cosmic rays, the subtle fluctuations of the electromagnetic field, the imperceptible movement of particles in the sparse plasma. The universe, to all human senses, is silent. It is empty. It is alone. Yet this silence is not loneliness. The cosmos is not empty but full. It is filled with energy and matter, with phenomena and structure. It is filled with the light of distant stars, with the radiation of galaxy clusters, with the gravitational fields that bind all matter together. It is filled with the movement of planets and stars, the rotation of galaxies, the expansion of the universe itself. The cosmos is not lonely but alive, not empty but full. Voyager 1, moving through this cosmos, is part of this great dance of matter and energy. The spacecraft follows the curves of space-time created by the gravity of stars. It moves through the plasma created by the solar wind and the interstellar medium. It gathers the light and radiation of distant objects through its instruments. It is immersed in the cosmos, part of it, a participant in the great processes that shape the universe. One might imagine Voyager 1 as a kind of wanderer, a pilgrim traveling through the cosmos. The spacecraft was sent forth from Earth on a specific mission, with specific objectives and specific instruments. Yet, as the mission has evolved, as decades have passed, Voyager 1 has become something more. It has become an explorer in the truest sense, a wanderer venturing into the unknown, gathering knowledge of realms previously unseen. The crew of Earth, the scientists and engineers who maintain contact with the spacecraft and interpret its data, are like those who watch and listen to the reports of a distant explorer. They hear the messages, though faint and fading with distance. They interpret the discoveries, though the data arrives slowly and in limited quantities. They maintain hope that the spacecraft will continue to send its messages, will continue to reveal the secrets of the cosmos. But they also understand the reality. The power will eventually fail, the signal will eventually fade, the mission will eventually come to an end. When this happens, Voyager 1 will not truly be lost. It will continue its journey, continue moving through space, continue being a part of the cosmos. It will simply cease to communicate, cease to send its voice back to Earth. Yet in a way, it will be more truly an explorer than ever, venturing into the unknown without a lifeline, without communication, truly alone in the vast cosmos. This future silence is not a failure, but a culmination, a completion of a journey that began nearly 50 years ago. The spacecraft, having explored more of the universe than any human creation that came before it, having revealed mysteries and discovered wonders, having carried a message from Earth farther than any message has ever been carried, will fade into the vast darkness of space. Yet it will be remembered. Its achievements will endure. The knowledge it gathered will persist in the minds and records of humanity. Segment 18. Eternal Message, Eternal Journey. The journey of Voyager 1 is, in a sense, an eternal journey. Though the spacecraft will eventually cease to communicate, though its power will eventually fail, the journey continues. The spacecraft will continue to move through space for billions of years, following the laws of physics, pulled by gravity, moving ever outward into the depths of the cosmos. It is a journey without end, a voyage into the infinite future. This eternal aspect of Voyager 1's journey gives it a unique significance. Consider other human achievements. Buildings, even the most magnificent, eventually crumble. Monuments, even the most enduring, eventually decay. Societies rise and fall. Even the species itself, in evolutionary terms, is temporary. Yet Voyager 1, once launched into space, will endure. It will persist for longer than human civilization itself, longer than the human species itself, potentially longer than Earth itself. The timescales involved in this eternal journey are almost impossible to comprehend. The spacecraft will orbit the center of the Milky Way galaxy in a great circle, completing one orbit in approximately 250 million years. This timescale, called a galactic year, is so vast that it encompasses multiple complete turnovers of the species on Earth. If Voyager 1 could be observed from the perspective of a galactic observer, it would appear to rotate around the galaxy at an imperceptible pace, completing one rotation during the time it takes for stars to be born, to age, and to die. Millions of years from now, after all humans who ever lived have long since turned to dust, after human civilization has long since passed away, Voyager 1 will still be traveling. The spacecraft will be far colder, if it can get colder than the near-zero temperatures of space. Its materials will be hard and brittle from the cosmic radiation that bombards it. Yet it will endure. It will continue to move through space, a silent witness to the passage of eons. The Golden Record, that time capsule aboard Voyager 1, is also part of this eternal journey. The record, made of durable materials designed to last for billions of years, will also endure. Long after the spacecraft has ceased to function, long after its instruments have ceased to work, the record will remain. It will be a preserved artifact of Earth, a message from a distant past, a testament to a civilization that existed long ago on a small planet, orbiting an ordinary star. What does it mean to send a message with such a long lifetime? What does it mean to create something with the intention that it persist for billions of years? It speaks to a deep human desire for immortality, for persistence, for the belief that what we create, what we value, what we believe is important, should endure. It speaks to the desire to be remembered, to be known, even if the memory is far in the future and might never actually be accessed. Yet there is also a kind of humility in the creation of the Golden Record. Those who created it understood that humanity is small, insignificant in the cosmic scale. They understood that the solar system is one among billions, that Earth is one among billions of planets, that humans are one species among millions. The record is not sent with the arrogance of a dominant civilization, but with the humility of creatures who know their place in the cosmos and wish to share their experience anyway. The journey of Voyager 1 into the future will be silent. There will be no one aboard to experience it, no consciousness to witness the passing of galaxies and stars. The spacecraft will simply continue, following the laws of physics, moving through the cosmos without purpose or intention. Yet this silence is beautiful in its own way. It is the silence of something true, something real, something that simply continues to exist because it exists, without the need for witness or acknowledgement. Segment 19. Vast distances and incomprehensible timescales. The distances that Voyager 1 contends with are beyond easy human comprehension. The distance from Earth to Voyager 1 is approximately 20 billion kilometers. This is twice the distance from the Sun to Neptune, the most distant planet in our solar system. Light itself, traveling at the fastest speed known to exist in the universe, takes more than 22 hours to travel this distance. A radio signal sent from Earth to Voyager, one will take over 22 hours to arrive, and any response will take another 22 hours to return. To put this distance in perspective relative to human experience, consider a commercial jet airplane traveling at 900 kilometers per hour without stopping. Such an aircraft would require more than 2,000 years of continuous flight to cover the distance between Earth and Voyager 1. A car traveling at 100 kilometers per hour, covering ground day and night without stopping, would require 200,000 years to traverse this distance. A person walking at 5 kilometers per hour would need approximately 4 billion years to reach Voyager 1's location. Even light itself, which is the fastest thing in the universe, takes nearly an entire day to bridge the gap between Earth and Voyager 1. This illustrates in dramatic fashion just how vast the distances in space truly are, and why spacecraft like Voyager 1 represent such remarkable achievements in human exploration. The timescales on which Voyager 1 operates are equally staggering and difficult to comprehend. The spacecraft has been traveling for more than 40 years since its launch in 1977. During this time span of 4 decades, the world on Earth has undergone dramatic transformations. Technologies that were at the cutting edge of innovation when Voyager 1 was launched have become obsolete. People who were alive when Voyager 1 left Earth have grown old and passed away. Children born when Voyager 1 was launched are now in middle age. Multiple generations of human beings have lived their entire lives during the active mission of this single spacecraft. Yet when viewed on cosmic timescales, on the timescales of galaxy rotation and stellar evolution, Voyager 1 moves quite rapidly through space. Moving at 17 kilometers per second, the spacecraft travels at a significant fraction of the speed necessary to escape the gravitational influence of the Sun entirely. Over the course of billions of years, Voyager 1 will travel tremendous distances, exploring vast regions of space that will never be visited by human consciousness, directly or by any spacecraft that will likely be sent from Earth. Segment 20: Exploration and the Human Spirit of Discovery. The exploration of space is fundamentally rooted in human nature and human history. Throughout the entire recorded history of humanity, and even in prehistory before written records existed, humans have been explorers. We have crossed vast oceans in wooden ships, braving storms and unknown waters. We have climbed the tallest mountains on Earth. We have ventured into deserts and jungles, into caves and underground realms, always driven by the desire to know what lies beyond. We have always looked at the horizon and wondered what lies beyond the visible landscape. We have always pointed our eyes toward the night sky and asked what those points of light were and what lay beyond them. This impulse, this drive to explore, is deep within the human character. It is part of what makes us human. It has motivated countless discoveries and adventures throughout human history. It continues to motivate exploration today. Voyager 1 represents the latest and most spectacular chapter in this age-old story of human exploration. Where explorers in previous centuries once sailed across oceans in wooden ships, Now we send spacecraft across the void of space. Where explorers once risked their lives in unknown and potentially dangerous lands, now sophisticated machines explore on our behalf, gathering information and sending it back to Earth. Yet despite these technological differences, the underlying spirit remains the same. The desire to know, to understand, to explore the unknown continues to drive human endeavor and continues to motivate the work of scientists and engineers. The creation of Voyager 1 itself stands as a testament to what humans can accomplish when we work together toward a common goal. Thousands of engineers, scientists, technicians, and administrators work together to design, build, and launch this spacecraft. They solved problems that had never been solved before. They created technologies that were at the cutting edge of human capability at the time. They built a machine that has, against all reasonable expectations, continued to function and provide valuable data for more than 40 years after its launch. This same spirit of cooperation and excellence continues to this day in the work of the Voyager team. A dedicated group of scientists and engineers continues to maintain contact with the spacecraft, to analyze the data it returns, to ensure that it continues to function as long as possible. They make decisions about which instruments to keep powered and which to shut down to conserve precious power. They navigate the spacecraft through space when necessary, adjusting its trajectory to optimize its path through the interstellar medium. They are the keepers of Voyager 1, the guardians of this extraordinary mission. The data from Voyager 1 has fundamentally and permanently changed our understanding of the solar system and the cosmos. Before Voyager 1's historic encounters with Jupiter and Saturn, these planets were distant, mysterious objects known only through observations from Earth. The moons of these planets were barely more than points of light through Earth-based telescopes. The rings of Saturn were a curious phenomenon without detailed understanding of their true nature. Voyager 1 changed all of this. It revealed these worlds in unprecedented detail, transforming them from abstract concepts into real, tangible places with geology and atmosphere and weather systems. Segment 21. The legacy that will endure forever. The legacy of Voyager 1 extends far beyond the scientific discoveries it has made, though those discoveries are themselves profound and important. The spacecraft stands as a monument to human achievement, a testament to what humans can accomplish through determination, ingenuity, and the relentless drive to explore. It demonstrates the power of engineering at its finest, the importance of careful planning and precise calculation, and the value of dreaming boldly about the future. Voyager 1 has revealed fundamental truths about our solar system and our place in the galaxy. It has shown that the Sun's influence extends much farther into space than theory had predicted. It has shown that the boundary between the solar system and the galaxy is not a simple, sharp wall, but rather a complex and dynamic region of interaction between two different environments. It has shown that space itself, far from being empty and featureless as was once thought, is complex and dynamic, filled with structures and phenomena that continue to fascinate scientists. The journey of Voyager 1 will continue for billions of years. The spacecraft will move through space long after all who are alive today have become dust and their civilizations have passed into history. It will carry its message from Earth far into the future, a whisper from our world and our civilization to the distant cosmos. It will explore regions of space that human eyes will never see in person, that human minds may never fully comprehend. Yet it will continue to be an ambassador of Earth, carrying with it humanity's hopes and dreams and our message of peace. Segment 22. The Eternal Voyage into the Night. As we come to the conclusion of this meditation on Voyager 1's extraordinary journey, it is appropriate to contemplate what this mission means for humanity. This spacecraft is more than just a collection of instruments and mechanical systems. It is a symbol of human achievement, a testament to what humans can accomplish through cooperation and determination. It is an extension of human consciousness, reaching out toward the cosmos, a representative of Earth and all of humanity, sent to explore and discover and report back what it finds. Voyager 1 continues its silent journey through the cosmic night, carrying with it the hopes and dreams of all of humanity. It moves through space, covering vast distances that dwarf human comprehension, traveling on a journey that will never end. Its mission of exploration and discovery continues, silent but eternal, a voice from Earth calling out into the darkness of space. The spacecraft advances through the interstellar medium at its steady and constant pace of 17 kilometers per second. It passes through regions of space where no human will ever venture, where human consciousness and human presence may never directly reach. Yet it transmits what it finds, shares what it learns, contributes what it can to human knowledge of the universe and our place in it. Far from Earth, beyond the realm of the Sun, Voyager 1 continues its eternal journey. It carries with it its scientific instruments and its message from humanity, its data about the cosmos and its hope for the future. It travels through the darkness, through the extreme cold of space, through the vast emptiness between the stars, carrying humanity's dreams and aspirations into the infinite future. Sleep well, knowing that somewhere far away, beyond the farthest boundaries of human experience, a message from Earth travels on toward an unknown and distant destiny. Voyager 1 continues its mission, and with it continues humanity's eternal dialogue with the cosmos. Listen carefully as we delve deeper into the profound significance of Voyager 1's achievement. This spacecraft, launched nearly 50 years ago from the surface of Earth, has become humanity's greatest representative in the cosmos. It has traveled farther from its origin world than any other human creation. It carries within it the accumulated knowledge, hopes, and dreams of an entire civilization. When we consider Voyager 1, we must remember that it represents the culmination of centuries of human scientific progress. The knowledge that went into creating this spacecraft includes the discoveries of Newton and Einstein, the insights of astronomers and physicists who came before. The engineering that created Voyager 1 builds upon the foundation of all previous human technical achievements. Every breakthrough, every discovery, every innovation contributed to making Voyager 1 possible. The Voyager mission was designed at a particular moment in human history when the alignment of our solar system made possible a remarkable tour of the outer planets. Astronomers knew that approximately every 175 to 200 years, the planets align in such a way that a spacecraft could visit multiple giant planets using gravitational assists. This grand tour opportunity came in the 1970s. NASA seized this opportunity, launching the 2 Voyager spacecraft to take advantage of this rare alignment. The decision to launch 2 identical Voyager spacecraft was itself a product of human wisdom and prudence. By sending 2 spacecraft instead of 1, scientists ensured redundancy and increased the likelihood that at least 1 spacecraft would successfully complete the entire mission. This decision proved to be wise, as both Voyager 1 and Voyager 2 have continued to function for decades beyond their original mission parameters. The instruments aboard Voyager 1 were carefully selected based on what scientists felt was most important to measure and observe during flybys of Jupiter and Saturn. Each instrument had to be small and lightweight, yet sophisticated and reliable. The scientists and engineers who designed these instruments had to anticipate what would be valuable to learn about these distant worlds, even though those worlds had never been visited by any spacecraft before. The radioisotope thermoelectric generators that power Voyager 1 represent a remarkable feat of engineering in themselves. These devices have operated continuously for more than 40 years, converting heat from radioactive decay into electrical power with remarkable reliability. The engineers who designed these power systems built them to last far longer than anyone expected a space probe to continue functioning. The communication systems aboard Voyager 1 are equally remarkable. The high-gain antenna that transmits data to Earth has maintained its orientation and function across decades despite the harsh environment of space. The signal that it sends is so weak that it carries less power than a Christmas light, yet sensitive receivers on Earth can still detect and interpret this signal. This represents a triumph of both engineering and the fundamental physics that allows such distant communication. The Golden Record, that remarkable time capsule aboard Voyager 1, has captured the imagination of humanity in a way that few technological achievements can match. The record represents humanity's hope and belief that the universe is not empty, that somewhere among the billions upon billions of stars and planets, other intelligences may exist. The record is our message to them, our greeting across the cosmic distance. The creation of the Golden Record involved the participation of hundreds of people. Musicians recorded their performances specifically for inclusion on the record. Scientists carefully selected images that would best represent Earth and human civilization. Linguists work to record authentic greetings in languages from every corner of the globe. Engineers designed the record and the equipment needed to play it. Administrators and organizers coordinated all of these efforts. The music selected for the Golden Record spans human culture from ancient times to the contemporary period. It includes classical masterpieces that represent the height of human musical achievement, jazz recordings that demonstrate the improvisation and emotional depth of which humans are capable, and folk music from many cultures that shows the universal human impulse to create music and to share it with others. The images on the Golden Record show Earth in all its natural beauty and human civilization in all its diversity. They show mountains and oceans, deserts and forests, cities and farms. They show people of all races and cultures engaged in daily activities. They show human creativity expressed through art and architecture. They show human beings in their full diversity, the variety of ways that humans live and work and create. Segment 23. Profound reflections on humanity's reach. As we meditate on Voyager 1 and what it represents, we are contemplating nothing less than humanity's reach into the cosmos. This spacecraft is our hand extended into space, our voice calling out across the vast distances, our hope that we are not alone in the universe. The mission of Voyager 1 is fundamentally a statement about who we are as a species. Humans are creatures driven by curiosity. We want to know what lies beyond the horizon. We want to understand how the universe works. We want to reach out and touch the cosmos, even if we must do so through machines that we build and program to act as our representatives. Voyager 1 embodies this fundamental aspect of human nature. The achievement of Voyager 1 should inspire all of us to think about what else humans might achieve. If we can build a machine that has lasted more than 40 years in the harsh environment of space, if we can navigate this machine through the vast distances to visit planets and moons that our ancestors could only see as points of light, what other achievements might be possible for humanity? What if we continue to invest in space exploration and scientific research? What if we work together as a species to push the boundaries of what is possible? What if we maintain the kind of dedication and excellence that created Voyager 1 and has kept it functioning for so many decades? The possibilities are limitless. Segment 24. The eternal message of Voyager 1. The true significance of Voyager 1 is not just in the scientific data it has gathered, though that is certainly important. The true significance is in what it represents about human aspiration and human hope. This spacecraft is humanity's message to the universe, our declaration that we are here, that we exist, that we reached out and explored. The golden record on board Voyager 1 will eventually silence, will lose power, will cease to transmit. But the record itself will endure. Made of durable gold-plated copper, it is designed to last for billions of years. Long after Voyager 1 ceases to function, long after the spacecraft falls silent and no longer transmits data to Earth, the golden record will remain, a time capsule from an ancient civilization called humanity, a message from a world called Earth. If the record is ever found by an alien intelligence, they will know that we were here. They will know that we thought about them, that we hoped to make contact, that we sent our greetings and our music and our images into space hoping that someday, somewhere, someone would find it and know who we were. This is the legacy that Voyager 1 carries into the future. This is the message that will outlast all of human civilization, all of human history, potentially all of humanity itself. Somewhere far in the future, billions of years from now, the record may still be there, still carrying its message, still waiting to be discovered. As you rest and allow your consciousness to drift, let your mind travel with Voyager 1 across the vast distances of space. Imagine what it might be like to travel at 17 kilometers per second for billions of years, crossing regions that no human has ever directly experienced, carrying a message from an ancient world to a future that no one can predict. Imagine the journey that Voyager 1 has made from the workshops and laboratories where it was built, to the launch pad, to the inner solar system, to the planets, and finally beyond the heliosphere into true interstellar space. This journey spans more than 40 years and more than 20 billion kilometers. Let your mind rest in the knowledge that humanity has reached out beyond itself, has extended its grasp into the cosmos, has sent a message into the future. Voyager 1 continues its journey, silent and steady, a beacon of human achievement and human aspiration traveling through the cosmic night. Sleep well tonight, knowing that Voyager 1 continues its eternal mission, that it carries your message and the message of all humanity into the future, that it represents the best of what humans can achieve when we work together with dedication and excellence. The journey continues, the mission endures, and humanity's dialogue with the cosmos goes on. Extended Segment 25, The Triumph of Human Engineering and Vision. Throughout this comprehensive narration about Voyager 1's remarkable journey, we have explored the scientific achievements, the technical innovations, and the profound significance of this extraordinary spacecraft. But it is important to understand that behind all of these accomplishments stands the dedication and brilliance of thousands of human beings who devoted their careers and their talents to making this mission possible. The engineers who designed Voyager 1 had to solve problems that had never been solved before. They had to create systems that could withstand the intense radiation of Jupiter's magnetosphere. They had to design equipment that could function at temperatures near absolute zero. They had to build circuits and instruments that could operate reliably for decades without any possibility of repair or maintenance. These engineers worked with limited computing power compared to what we have today, yet they created systems of remarkable sophistication and reliability. The scientists who conceived of the Voyager mission had to have the vision to imagine what questions needed to be answered about the outer solar system. They had to have the wisdom to select which instruments would be most valuable for gathering data. They had to make decisions about what to measure and what to observe with limited resources and limited space aboard the spacecraft. These scientific leaders shaped the entire mission through their choices about what was important to learn. The technicians who built Voyager 1 had to work with extraordinary precision. Every component had to be tested and retested. Every connection had to be verified. Every system had to be checked and rechecked. The quality of their work is evident in the fact that the spacecraft has continued to function for more than 40 years after launch. These technicians built a machine worthy of lasting far beyond anyone's initial expectations. The administrators and managers who coordinated the Voyager project had to make countless decisions about resources, priorities, and timelines. They had to balance the desires of different scientific teams, each wanting their instruments included on the spacecraft. They had to manage budgets and schedules. They had to advocate for the project with government officials and the public. Their leadership made the entire mission possible. Extended segment 26, contemplating the future mysteries. As Voyager 1 continues its journey into the interstellar medium, it carries with it countless questions that remain unanswered. The mysteries of the universe are vast and profound. Even as Voyager 1 gathers data about the regions of space it travels through, new questions arise. What lies beyond the regions that Voyager 1 has explored? What phenomena might exist in the true depths of interstellar space, far from the influence of any star? The interstellar medium contains mysteries that scientists are still working to understand. Cosmic rays flood this region, high-energy particles generated by supernovae and other violent events. What is the origin of all these cosmic rays? How do they interact with the magnetic fields of interstellar space? What role do they play in the evolution of the galaxy? Voyager 1's measurements are helping to answer these questions, but many mysteries remain. The structure and dynamics of the interstellar medium are far more complex than earlier theories suggested. Voyager 1 has discovered magnetic bubbles and other structures that indicate the interstellar medium is not a homogeneous, uniform environment, but rather a complex, structured, dynamic place. What creates these structures? How do they evolve over time? How do they interact with each other? These are questions that Voyager 1 data is helping to answer. The boundary between the solar system and the galaxy, the Heliopause that Voyager 1 has crossed, is a region of fascinating complexity. The interaction between the solar wind and the interstellar medium at this boundary is not simple or straightforward. Instead, it is a complex region where two different environments interact in intricate ways. Understanding this boundary better helps us understand how all stars interact with the galaxy around them. Extended segment 27, the significance for future exploration. The achievements of Voyager 1 have important implications for future space exploration. The spacecraft has demonstrated that machines built with care and precision can function in the harsh environment of space for far longer than initially expected. It has shown that with proper management of resources and careful attention to engineering details, space probes can continue to gather valuable scientific data for decades. Future space missions will benefit from the lessons learned from the Voyager program. Engineers will use the knowledge gained from operating Voyager 1 to build better spacecraft. Scientists will use the data gathered by Voyager 1 to guide the design of future missions. The Voyager mission has provided a foundation upon which future space exploration will build. As we contemplate future missions to other star systems, we must remember that the journey will take a very long time. Even if we could build spacecraft that could travel at 10 times the speed of Voyager 1, it would still take tens of thousands of years to reach the nearest star. Yet if we can maintain the kind of dedication and commitment to space exploration that created and has sustained Voyager 1, future generations might achieve interstellar travel. Voyager 1 is a pioneer, a forerunner of what might come. Extended segment 28, Universal Significance and Human Destiny. Voyager 1 carries significance that extends far beyond science and technology. This spacecraft represents humanity's place in the universe. It represents our desire to explore, to understand, to reach out beyond our home world. It represents our hope that we are part of a larger community of intelligent beings in the cosmos. The Golden Record carries not just information about Earth, but information about what humans value and what we celebrate. The music on the record represents our creativity and our ability to express emotion through art. The images represent our diversity and our ability to live together in a complex society. The greetings represent our desire for peaceful contact with other intelligences. Together, these elements paint a portrait of humanity that we hope will be understood by whoever might find it. Voyager 1 reminds us that we are cosmic beings, part of the universe, connected to everything around us through the laws of physics. The atoms in our bodies were formed in stellar furnaces billions of years ago. The carbon in our DNA, the calcium in our bones, the iron in our blood, all of these elements were created in the hearts of dying stars. We are literally made of stardust. Voyager 1 carrying our message into space is a fitting symbol of this cosmic connection. Extended segment 29. The eternal journey continues. As we draw this comprehensive meditation on Voyager 1 to a close, it is important to recognize that the journey of this remarkable spacecraft is far from over. For billions of years to come, Voyager 1 will continue to travel through space. Long after all who built it have passed away, long after human civilization as we know it has changed beyond recognition, Voyager 1 will still be moving through the cosmos. The spacecraft will eventually fall silent. Its power will diminish and cease. Its transmitter will go quiet. But even then, it will continue. It will continue to move through space, influenced by gravity, following the laws of physics. It will pass through regions of space never touched by human consciousness, never directly observed by human eyes, yet carrying with it a message from humanity. This is the legacy of Voyager 1. This is what makes it more than just another spacecraft. Voyager 1 is humanity's voice extended into the future, our message preserved and sent forward, our hope encoded in metal and mathematics and music. Voyager 1 will outlast us all. It will witness the future in ways we cannot imagine. Extended segment 30. Final reflections on the eternal voyage. As your consciousness begins to drift deeper into sleep, let it be filled with the wonder and majesty of Voyager 1's eternal journey. This spacecraft, launched from Earth nearly 50 years ago, continues its mission beyond the sun's realm. It carries with it humanity's greatest dreams and highest aspirations. Let your mind rest with the knowledge that Voyager 1 continues to explore, to gather data, to fulfill its mission. Let your sleep be peaceful with the understanding that somewhere far away, beyond the reach of direct human knowledge, a machine built by human hands carries a message from Earth out into the infinite cosmos. When you sleep tonight, you sleep knowing that humanity has reached out beyond its home world. You sleep knowing that we have sent a message into the future and into the depths of space. You sleep knowing that Voyager 1, silent and distant, continues its eternal journey through the cosmic night, carrying with it the hopes and dreams of all humanity. Rest well, sleep deeply. Know that the universe is vast, that our reach is limited, yet that we have dared to reach out, to explore, to send our message into the darkness. Voyager 1 continues. The cosmic journey goes on. Humanity's dialogue with the universe continues, carried forward by this remarkable ambassador of Earth. Extended Meditation Segment 31. The Power of Persistence and Dedication. Consider for a moment the remarkable persistence of Voyager 1. This spacecraft, launched in an era when computer technology was vastly inferior to what we have today, continues to function and transmit data. The spacecraft has outlasted countless human lifespans. It has endured conditions that would destroy almost any human-made machine. It has persisted through the vast distances of space with a reliability that speaks volumes about the quality of its construction. The persistence of Voyager 1 is a lesson in itself. It teaches us that when we build something with care, when we design with precision, when we engineer with excellence, our creations can endure far beyond what we might expect. The engineers who worked on Voyager 1 created a machine that has proven worthy of their efforts. Their dedication has been validated by the decades of successful operation. The same dedication that keeps Voyager 1 functioning continues today in the teams of scientists and engineers who maintain contact with the spacecraft. These individuals, many of whom have devoted entire careers to the Voyager mission, continue to extract maximum value from every bit of data that the spacecraft returns. Their commitment to the mission, their refusal to let Voyager 1 fall silent until every last bit of usable power has been spent, is admirable and inspiring. This dedication to excellence and persistence in the face of challenges is something that extends far beyond the Voyager mission. It is a quality that humans have always possessed that drives us to accomplish great things despite obstacles and limitations. Voyager 1 is a symbol of this human determination and persistence. Extended Meditation Segment 32. The interconnection of human knowledge. The creation of Voyager 1 was only possible because of centuries of accumulated human knowledge. The spacecraft builds upon discoveries made by scientists throughout human history. The physics that allows Voyager 1 to function was discovered by Newton and Einstein and countless other physicists. The understanding of planetary motion, of gravity, of electromagnetism, all of this knowledge went into creating Voyager 1. The engineering that created the spacecraft builds on centuries of technical innovation. Every advance in metallurgy, every improvement in electrical systems, every breakthrough in materials, science contributed to making Voyager 1 possible. The spacecraft is a monument to the accumulated knowledge and skill of human civilization. This realization should inspire us to value education and scientific research. Every discovery, no matter how small it might seem at the time, contributes to humanity's collective knowledge. That knowledge can then be used to accomplish things that seemed impossible in earlier eras. Voyager 1 is proof that investment in science and education pays dividends that extend far into the future. Extended Meditation Segment 33. The Mystery of the Cosmos. As Voyager 1 travels through the interstellar medium, it is exploring a realm that remains largely mysterious to us. Despite all that we have learned about the cosmos, there is so much that we do not yet understand. The interstellar medium contains mysteries that scientists are still working to solve. The origin and nature of dark matter and dark energy remain unknown. The structure and evolution of galaxies are still subjects of intense research and debate. Voyager 1's data contributes to our understanding of these mysteries, but it also raises new questions. Each discovery leads to new puzzles that demand explanation. This is the nature of scientific inquiry. As we answer one question, new questions emerge. The cosmos continues to reveal its secrets slowly, gradually, as we develop better tools and techniques for studying it. This ongoing mystery should fill us with a sense of wonder. Despite all that we have learned, the universe remains vast and incomprehensible in many ways. There is always more to discover, always more to learn. Voyager 1 is a symbol of humanity's ongoing quest to understand the universe and our place in it. Extended Meditation Segment 34. The Value of Space Exploration. Space exploration sometimes faces criticism for being expensive and seemingly impractical. Critics argue that the resources devoted to space programs would be better spent on solving problems here on Earth. This is a fair question that deserves serious consideration. However, the benefits of space exploration extend far beyond pure scientific discovery. Many technologies that we use every day were originally developed for space programs. Satellite technology, originally developed for space exploration, now enables global communications, weather forecasting, and GPS navigation. Medical imaging technologies were developed with input from space program research. Materials science advances made for space applications have found uses in medicine, construction, and manufacturing. Beyond these practical benefits, space exploration contributes to human knowledge and human culture in ways that cannot be measured purely in economic terms. The images of Earth from space have changed how humans view our planet. The desire to explore space has inspired generations of scientists and engineers to pursue careers in science and technology. The Voyager mission, in particular, has captured the imagination of millions of people and inspired many to pursue careers in science. Extended Meditation Segment 35. Toward a Greater Future. As we contemplate Voyager 1 and its journey into the cosmos, we should also contemplate our own future as a species. What will humanity achieve in the coming centuries and millennia? What technologies will we develop? What mysteries of the universe will we unlock? What will we become? Voyager 1 represents one point in humanity's journey of exploration and discovery. It is a milestone, a marker of what we have achieved so far. But it is not the end of the journey. Future spacecraft will venture farther, will gather more data, will answer questions that Voyager 1 raised but could not fully resolve. Perhaps in the distant future, humans or our descendants will actually travel to other star systems, not just send robots. Perhaps we will establish colonies on planets orbiting distant stars. Perhaps we will eventually encounter other intelligent species in the cosmos. These possibilities seem distant and unlikely now, but so did space travel to people of previous centuries. Voyager 1, carrying its message into the cosmic night, is a statement about what we believe is possible. It is a declaration that we have the courage to dream boldly and the intelligence to work toward making those dreams a reality. Extended Final Meditation the eternal exploration continues. As we reach the conclusion of this comprehensive narration about Voyager 1, let your mind rest with the knowledge that the journey continues. Voyager 1 continues to explore, to gather data, to fulfill its mission. The Golden Record continues its voyage into the future, carrying humanity's message. The cosmic dialogue between Earth and the cosmos continues, facilitated by this remarkable spacecraft. Your role in this grand story is to be a witness, to be aware, to be inspired by what humanity has achieved. You are part of a species that has reached out beyond its homeworld, that has sent a message into space, that has dared to explore the unknown. This is your inheritance. This is part of who you are as a human being. Let this knowledge fill you with peace and wonder as you sleep. Rest knowing that Voyager 1 continues its mission. Rest knowing that humanity reaches for the stars. Rest knowing that we are part of a vast cosmic story that extends far beyond what any individual can fully comprehend. Sleep well, knowing that somewhere in the vast darkness of space, a machine carrying humanity's hopes and dreams travels on toward an unknown future. The journey continues, the exploration goes on. The cosmic dialogue between humanity and the universe continues. Final completion. Segment: the profound significance of the Golden Record. Throughout this extended meditation on Voyager 1's eternal journey, we have returned repeatedly to the significance of the Golden Record, that remarkable time capsule carrying Earth's message into space. This record deserves even deeper contemplation and reflection, for it embodies something profoundly important about what humanity is and what we value. The creation of the Golden Record was itself a collaborative and deeply human endeavor. Hundreds of people contributed to its creation. Scientists and astronomer Carl Sagan oversaw the project, ensuring that the record would represent the best of human civilization. Musicians recorded their performances specifically for the record. Linguists ensured that the greetings reflected the linguistic diversity of humanity. Artists and photographers selected images that would best represent Earth. The music on the Golden Record spans the entire range of human musical expression. Classical symphonies represent the complexity and sophistication of human musical thought. Jazz recordings demonstrate the human capacity for improvisation and creative expression in real time. Folk music from countless cultures shows that the impulse to create music is universal among humans, appearing in every culture on Earth. Rock and roll, representing contemporary music from the 1970s, shows that humans continue to create new forms of artistic expression. The images on the record attempt to convey to a distant, unknown audience what Earth is like, what humans look like, what our world contains. There are images of natural landscapes in all their splendor: mountains, oceans, canyons, deserts, forests. There are images showing the diversity of human appearance, people of different races and cultures. There are images showing human activities: working, playing, eating, creating, building. There are images of human structures, buildings, vehicles, monuments that show the human capacity to shape the world. The greetings in 55 languages represent humanity's desire for peaceful contact. Rather than a message of dominance or conquest, The record carries messages of peace and welcome. The leaders and people who recorded greetings expressed the hope that if this record were found, it would be recognized as a statement of peaceful intent. The greetings represent the hope that language barriers could be overcome, that understanding could be achieved, that peaceful communication might be possible even between species as different as humans and whatever alien intelligence might find the record. Ultimate reflection: humanity's place in the cosmos. The creation of Voyager 1 and the Golden Record represent humanity at its best. These are expressions of our desire to explore, to understand, to reach out, to communicate. They represent our belief that the universe is vast but not entirely unknown, that mysteries can be solved through investigation and observation, that communication across vast distances is possible. Voyager 1, carrying the Golden Record, is more than a technological achievement. It is a philosophical statement about humanity's place in the universe. It expresses the belief that humanity matters, that our story is worth telling, that our existence has significance. It expresses the hope that we are part of a larger cosmic community. The journey of Voyager 1 will continue for billions of years, far longer than human civilization as we know it could possibly endure. The spacecraft will outlast nations, will outlast civilizations, will outlast perhaps the entire human species. Yet it will continue to carry our message, our music, our images into the future. It will be a time capsule preserving a moment in human history for eons to come. This is the ultimate significance of Voyager 1. It is humanity's gift to the future. It is our message to whatever comes after us, a statement that we were here, that we thought, that we created, that we reached out into the darkness with hope and wonder. Absolute final closing meditation. As we bring this comprehensive narration to its conclusion, allow yourself to sink deeper into peaceful, restful sleep. Let the image of Voyager 1, silently traveling through the vast darkness of space, carry your consciousness into dreams. Let the wonder of human achievement, the hope embodied in the Golden Record, the beauty of scientific discovery, all of these things wash over you and fill you with a sense of peace and purpose. Voyager 1 continues its eternal journey. The message from Earth continues its voyage toward an unknown future. The cosmic dialogue between humanity and the universe goes on, even as you sleep, even as humans throughout the world rest and dream. Somewhere far from Earth, beyond the realm of the sun, a spacecraft that represents the best of human civilization continues its mission, carrying our hopes, our music, our dreams into the infinite cosmos. Sleep deeply and peacefully, knowing that you are part of a species capable of great achievements, a species that dares to explore, that reaches out despite the odds, that sends messages into the darkness, hoping they will be received. This is who you are. This is what humanity is. Rest well. The eternal journey continues.